You are welcome to chemistry class with Anekwe Christopher Ejike. You are a chemistry teacher that has been handling you on topics in chemistry. And this particular video, we'll be looking at the topic titled carbon. 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 That is what we want to look into. Carbon as one of the elements in the periodic table, we'll look into it. And it's expected by the end of this particular class, you should be able to explain the structure of carbon. You should be able to list the allotropes of carbon. You should be able to state the differences between diamond and graphite. And lastly, you should be able to explain the combustion of carbon allotropes. So these are the 4 things we want to achieve by the end of this particular class. For that reason, we are going to follow them one after the other by first of all starting with what carbon is and the structure before other ones follow suit. So first of all, what is carbon? Carbon, of course, is an element, one of the elements in the periodic table. It's a nonmetal found in the group 4 of the periodic table. It occurs naturally as diamond and graphite. It's a non-metallic element in the periodic table. It belongs to group 4 of the periodic table. Now, it occurs naturally as diamond and graphite. Also, it occurs in an impure form as coke, and in combined state as petroleum, which is crude oil, wood, and natural gases. These are the areas that we can get carbon in a large quantity. We can have it in all these places, and there some are impure, some are in a combined states, and that is carbon for you. How does it look like, the structure of it? What are the bondings of carbon? That takes us to atomic structure of carbon. Of course, I said that carbon belongs to group 4 of the periodic table, but carbon ordinarily has 6 electrons in the atmosphere. That means it's the 6th element in the periodic table. As you go from hydrogen to helium to lithium to beryllium to boron, then carbon, as you move along, is the 6th element. Now the 6th element, in the nucleus of that atom, it has 6 protons, 6 neutrons, and so it's also surrounded by 6 electrons. What am I just trying to say? Inside the nucleus of that atom, it has 6 protons, 6 neutrons, and 6 electrons. Now that revolves around the shell. That 6 electrons that revolves around the shell, 2 are in the first energy level, which is the K shell, in the inner shell. Now 4 are in the second energy level, which is L shell. And that particular L shell, the outermost shell, is what gives it the 4 group that it belongs to. Is that particular 4 valence that in the outermost shell that makes it to belong to that group 4 of the periodic table, that we said that carbon belongs to group 4 because it has 4 electrons in the outermost shell. But altogether, it has 6 electrons, both in the outermost shell and the inner shell, which is K shell and L shell. Now, each orbital configuration is what? 1s2, 2s2, and 2p2. 2, 2, 2. Together, you add it up together, you're going to have 6 electrons. That is the structure, that is the configuration of it. Now, carbon atom has 4 valence electrons. I said it before. And because of it, carbon has a unique property. It has a unique ability, which we say that carbon atoms are able to catenate. What do we mean by that? Ability of carbon atoms to join to one another by covalent bonding or covalent bond in a continuous fashion. Now, ability of carbon to carbon bond, carbon to bond in a continuous chain. And such phenomenon is what we call catenation. So carbon has that unique property. Carbon has that unique ability to bond with each other to form a long chain. Such phenomenon is called catenation. Catenation. All right, we are going to look at it this way by moving further to discuss the allotropes of carbon. Carbon can exist in diverse ways. We have what we call allotropy. Allotropy, which such form is allotropes. Now, allotropy, don't be confused with issue of allotropes and allotropy. Allotropy is just existence, just like a phenomenon. Is the existence of an element with the same physical state, but in different forms. Is the existence of an element in the same physical state, but in different form. The various forms are called allotropes. Carbon can exist in the same physical states, but different forms. Like carbon now exhibit such a thing. And other elements also exhibit that. Something like sulfur, tin, oxygen, phosphorus, and others. But carbon has two unique allotropes, crystalline allotropes of carbon. We have two. Note this. Of course, we have other forms of carbon, but they are amorphous in nature. But the crystalline allotropes of carbons are two. They are diamond and graphite. Diamond and graphite, because these ones are crystalline. They have shape. They can be described. They are not amorphous. They are not powder. They are not shapeless. Now, we have other ones, but those ones are amorphous carbon. We call them amorphous carbon. That has to do with coke and coal and all of that, carbon black and the sugar charcoal and all of that. So they belong to the group we call amorphous carbon. So, but allotropes of carbon or crystalline allotropes of carbon are diamond and graphite. Please take this seriously, and that is it. So, existence of such elements in the same physical state, but in different form is what we call allotropy. All right, let's look at diamond now. Diamond, that is one of the allotropes of carbon. The structure and the bonding. In diamond structure or diamond bonding, each carbon atom is at the center of a regular tetrahedron and covalently bonded to 4 other atoms in the strong compact fashion. Each of the carbon atom is bonded, is covalently bonded to other 4 atoms in a strong compact fashion. The covalent linking between the atoms is continuous to produce a single infinitely log 3-dimensional giant or micromolecule, which has a network octahedral structure. As you can see in this, we are going to see in the structure below. It has a giant 3-dimensional shape. Now, we call the structure or the shape of diamond as octahedral structure. Look at it. Diamond is being linked this way. It's been fixed that each of the carbon atom is being fixed with 4 other carbon atom linking to it and tightly held. And because of the rigidity of the structure, the rigidity of the structure is responsible for the hardness of diamond. Because of the rigidity of the structure, it makes diamond to be very hard. That is to say, and that gives it the opportunity or the privilege to be the hardest known substance Diamond is the hardest known substance. Since the covalent bonds are strong and the molecule is compact, the melting point of diamond in form of diamond is very high. That means diamond has high melting point because it's very, very hard. It's the hardest known substance. The structure is on the left hand side, but the graphite is the other one on the right hand side. Now, what are the physical properties of such diamond? Pure diamond is very hard. It's very, very hard. It's colorless and transparent. Number two physical properties of diamond is that diamond forms octahedral crystal with high refractive index. Number three is that it is very hard. It is very, very hard. It has a density of 3.5 gram cm cube per cm cube, a melting point of 3,600 cm cube. So it has a very high boiling melting point, It does not conduct electricity. Why? What is the reason? Because all of the 4 valence electrons per molecule of carbon atom are used in the bonding. So no mobile electron. Note this, it's very, very important. Diamond does not conduct electricity because there is no mobile valence electron. All of the bonding, all the carbon atoms are being used in the bonding. Number 5 physical properties of diamond is that it is insoluble in any solvent, whether polar, liquid, water, or non-polar solvent is insoluble in all of them. All right, now what can we use diamond for? Because of its high refractive index and amazing metallic luster, when cutting, so it is used in jewelry. Number 2 is that it's being used, because of its hardness again, diamond is used in cutting glasses, in drilling rocks, in boring of holes, in making bearings, an engine, and an abrasive, which means that it's being used to smoothen rough surfaces. We use diamond to do that because it's very, very hard. It can rock with any metal and still smoothen it. It's very, very hard. It's being used to smoothen rough surfaces. That's number 2. All right, let's look at the other part of allotropes of carbon. We have discussed, we said that we have 2 allotropes of carbon. One is diamond and that one is graphite. Now, what is graphite and how is the structure looks like? Now look at the structure of graphite. You can look at it that there is layer. It has layers, and it has a linkage between each layer, van der Waals bonds that are holding the layers, which we know that van der Waals forces or van der Waals bonds are not strong. The structures are in layers. Covalent bond is actually, of course, what holds it, and we see the dimension or the diameter of it. So we're going to look at it briefly by saying that in graphite, each carbon atom is covalently bonded. Of course, we saw it in the structure to 3 other atoms, produced an infinite 2-dimensional. That of the diamond is 3-dimensional, but this one is 2-dimensional, hexagonal layer structure, which is strong and hard. We saw it in the diagram we presented above. It has a hexagonal structure. Of course, the structure is also hard, but it's not that of the diamond. The flat hexagonal layer in graphite are held together by the weak van der Waals attractive forces, which allow movement of planes parallel to each other and makes the graphite to be soft and slippery. Now look at the diagram once again. We can look at the van der Waals forces, attractive forces is holding it, and we know that it's a weak force. We can see the covalent bond between holding the carbon atom, but because of the force holding it is not as tight as that of the diamond, it makes it soft. It makes it slippery, and it makes it that it's not as hard as that of the diamond, and is of advantage to this graphite aspect of it. The shape is hexagonal, while the other one is octahedral structure. All right, the fourth electron in the valence share of each carbon atom in graphite is mobile. Diamond, the 4 electrons in the atomous shell of carbon is being used in the bonding. For this one of graphite, 3 are being used, the other one is remaining. That means free to move. That is why we call it mobile electron. It has 1 mobile electron. And because of it, it's not being used in the bonding and accounts for its electrical conductivity. Meaning, what does it mean? Diamond can conduct electricity. It has free mobile electron that can move, but diamond is not like that. Graphite can conduct. So it's one of the differences. All right, now let's look at the physical properties of graphite. Graphite forms soft, black and opaque hexagonal crystal, which are greasy to feel when you touch it. The softness due to the ability of the adjacent layer to slide on one another. Of course, we saw the layer, we saw the bond that is holding it, and the van der Waals forces that are holding the layers. So it's soft and easily to slide on one another. It is hard, of course, it's still hard, but the density is not as that of the diamond. The density is 2.3 grams per cm cube and melts as about 3,500 degrees Celsius, while that of the diamond is 3,600. So this one is lesser than that of the diamond. It's a good conductor of heat and electricity. Why? What is the reason? Because of the presence of the mobile electron per carbon atom on it. These are the differences we can also use to differentiate the 2 of them. Number 4 is that it is soluble in any solvent. Graphite is an example of non-metallic conductor. It is metalloid. Of course, we know that non-metals are not good conductor of heat and electricity, but when carbon exists as graphite, it conducts electricity. It's one of the non-metallic elements that conduct electricity. That is why it belongs to what we call metalloid, because it has metallic character. That is it. And what can we use it for? Diamond is used as lubricant because it is soft. Of course, insoluble in water and heat resistant. Number 2, used as inert electrodes. Yes, during electrolysis and for brushes of electric motor, being a good conductor of electric current. We use it for electrodes, as an inert electrode in our electrolysis. That is why sometimes you hear carbon electrode. That carbon electrode that you hear, maybe when having an electrolysis of acidified water, or dilute tetraoxide of S6, or concentrated sodium chloride, or anyone, you hear carbon electrode. That carbon electrode is when it's being used, when graphite, carbon exists as graphite. It's the graphite that is actually that carbon that you do here. That is it. We use it in electrolysis as an electrode. All right. When mixed with clay, graphite forms lead, which is used in making lead pencil. Of course, we know. We use it in lead pencil, and the hardness of a pencil depends on the amount of clay in the mixture. Soft pencil contains some amount of graphite, while hard pencil contains more of clay. So small amount of clay will give us soft pencil, while hard pencil contains more of clay. But altogether, graphite is being used on it. Then number 4 is that it's being used in making crucible. Because of its high melting point, it's being used in nuclear reactors, being soft and with high melting point. So we can use it in all these places, and any of them can be used around you, and that also makes graphite or carbon very, very important to us, either as a diamond or as a graphite. All right, let's now compare the two of them. Based on what we have talked so far, we can differentiate carbon, diamond from graphite. Two of them, they are all carbon, but different allotropes. Now, diamond is transparent solid that sparkles when cut and polished. But graphite is an opaque solid with metallic luster. It is octahedral in shape, which is what? Diamond, while that of the graphite is hexagonal in shape. These are the differences. The density of diamond is 3.5, while that of the graphite is 2.3 gram per cm cube. Diamond is a poor conductor of heat and electricity, while there is no mobile electron, while that of the graphite is a good conductor of heat and electricity. Diamond is an inert substance, but at about 390 degrees Celsius, it burns in air to form carbon 4 oxide and combines with fluorine. Graphite is more reactive substance, burns in air to form carbon 4 oxide at 700 degrees Celsius. It also reacts with oxidizing agents to form oxides. It also reacts with fluorine and triazosulfate 4 acids. Diamond is the hardest known substance. It's the hardest substance known, while that of the graphite is one of the softest minerals known. Okay, we want to look at this particular aspect of it before we cap it up. Combustion of carbon allotropes. Of course, carbon burns in limited supply of air to form carbon 2 oxide. When carbon burns in air with limited supply of air, it will give carbon 2 oxide. The equation for the reaction is below. But in excess air, when there is a full supply of air, carbon 4 oxide will be formed. Carbon 4 oxide will be formed. All right. When charcoal is used as fuel, it burns to release. Release is used for cooking. Of course, charcoal, we know that we use charcoal for our cooking, and that charcoal you are seeing is also a carbon. Note that carbon occurs most abundantly, both naturally as diamond and graphite, and in numerous compounds, including petroleum, coal, natural gas, among others. So far, we have discussed so many things, both the combustion of carbon allotropes, the physical differences between carbon and between diamond and graphite, the physical properties of each of them, the structures of diamond and graphite, allotropes of carbon, which is diamond and graphite, and what carbon is, and in the summary of it, we say that carbon is a non-metal found in the group 4 of the periodic table. That carbon atoms are able to catenate and can exhibit allotropes. The two allotropes of carbon, we said it before, and we are saying that they are diamond and graphite. Take it seriously, and for further discussion and inquiry, do well to still contact me, but you do this assignment for your own. Now, give one physical properties of diamond. Number 2, graphite. B, give 2 uses of diamond. State one evidence that shows that both diamond and graphite are allotropes of carbon. This is WAEC question 1989, number 3. WAEC question 2016, number 5 states that state 2 ways in which the structure of diamond and graphite are similar? What are the two ways you can explain that the structure of diamond and graphite are similar? WAEC 2016, number 5. Lastly, last question assignment that you will do is number 1, 2010 WAEC question. Number 1 says, explain why graphite is used as lubricant. We talked about it in this class, in this particular video. Then number II of it says, diamond is used as industrial cutting tools. Why do we use diamond as cutting tools? We discussed it because they are very hard. Because of their hardness, they can be used as that. Lubricant, we talked about the structure and the nature of graphite. So finally, for further inquiry and discussion with me, use my phone line, which is +234 80655 73229. And you can send me email at christo116@gmail.com for further discussion and inquiry. Thank you for being part of this particular class, and remain blessed as you look up to the next video. Thank you.